Hey guys, I'm Amit Kumar and welcome to this video in which we are going to talk about decimal, binary and interconversion. Though this topic is not related to Apex, but we are going to discuss about bitwise operation, and for that you should have an idea about binary numbers. So this is basically for them who are not having any idea about decimal and binary numbers. So number system. Number system is a defined set of rules to form numbers with a defined set of digits. So number system defines a set of rules according to which it forms numbers. Different number systems have different number of digits. There are different types of number systems available to us, and some of them are decimal, binary, octal and hexadecimal number systems, where decimal is having 10 digits, binary is having 2 digits, octal is having 8 digits and hexadecimal is having 16 digits. Decimal number system is used by humans in daily life, whereas rest of them are mostly used in computer. As most of them are having some common digits, hence numbers formed in each system use radix or base, that is the number of digits in the system. So you can see there are few digits which are very common, like all the number systems are having digits 0 and 1. Decimal, octal and hexadecimal are having digits from 0 to 7 which are common, and if I talk about decimal and hexadecimal, they are having 0 to 9 common digits. So if we form number in any number system, it will be very difficult to distinguish in which number system we are writing. So we use a radix or base to distinguish between them. The syntax to write a number with radix or base is something like this, where number is written and the base or radix is written as the subscript. You can see 100 is written in all the number systems and they have different value actually, and we are distinguishing between them with help of their base or radix. In each number system, numbers are formed from the lowest digit to the highest digit, and once all the digits are over, then the number of digits is increased in the number. So we start with single digit number and we write down from the lowest to the highest digit, and once we have written all the digits for a single digit number, then we make 2 digit numbers. And the same rule applies to all the number systems. You can clearly see in the table how we write numbers in decimal, and we are having idea about it. We have written from 0 to 9, and since all the digits are over, then we start writing 2 digit number, so it becomes 10, 11, 12 up to 19, then 20, 21, 22, and like that we go on up to 99, and then after all the digits are done in 2 digit number and we start writing 3 digit numbers. Similarly, the same rule applies to binary numbers, but here there are only 2 digits, so 0 and 1, and then we move on to 2 digit numbers, so 1011, then 3 digit number 100, 101 and so on. And the same rule applies to octal and hexadecimal as well. This is just to give you an idea how numbers are formed. Now let's talk about how to convert a decimal number to a binary number. Suppose we are having 125 in decimal and we want to know what's the equivalent binary of it. The process is very simple. We will start dividing it by 2 and noting down the remainders on the right hand side. So you can see 125 divided by 2, we get a quotient 62 and remainder is 1. Again we do that, 31, remainder 0, and we keep on doing it until unless we get a number less than 2, or in other words you can say we get a 1. Once the division is over, we note down these remainders from bottom to top. So it is 1111101, and that's the equivalent binary number. Now let's see how to convert a binary to decimal. So suppose if this is the binary number 101011 and you want to know what's the equivalent decimal of it, we will note down the digits and then we will note down the place values starting from the right, and we start counting from 0. So it will be 0, 1, 2, 3, 4, 5. The formula to convert is digit multiplied by 2 to the power of place value plus digit multiplied by 2 to the power of place value. So if we'll follow the formula, these digits will be written as 1 into 2 to the power of 5 plus 0 into 2 to the power of 4 plus 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 1 and plus 1 into 2 to the power of 0. Once we have written the formula, we just need to do the power and the multiplication, and after that the division, which will result into 43. So 1011 in binary is equivalent to 43. Don't worry, you need not to do that much of calculation every time, because you are having one smarter device known as calculator. Now if you are having your calculator, you can click on this menu and go to the programmer section, and here you can write down any decimal or any binary and get the equivalent of it. You have to click on that switch of the number system. Suppose I want to write decimal, so I will click on this DEC and then I will write down 125, and to know the binary of it I will just click on bin or binary. So you can see 1111101, which is the same. Now if you want to convert binary to decimal, click on binary and note down the binary number, which is 101011, and then click on decimal to know the decimal of it. You might have noticed whenever you are writing down the number, it is also showing the corresponding number in different number system. Now if we are already having calculator, what's the idea behind telling you this? Because you should know how decimal to binary or binary to decimal conversion happens. The same rule applies if you are converting any specific number system to binary and any binary to any other specific number system. So guys, that marks the end of this video. See you soon in the next video. Till then, thank you and take care.